So in this lesson, we're going to take a look at dividing polynomials. There's a couple of different ways we can divide polynomials. We can take this polynomial and divide it by a monomial, meaning one term. We can take a polynomial of two or more terms and do division with that. And we can just also divide larger amount of term polynomials. So the first thing we're going to look at is the easiest case, which is dividing a polynomial by a monomial. To divide a polynomial by a monomial, you divide each term by the monomial given. Then you're going to rewrite the quotient and the lowest term. So it's kind of like reducing a fraction. So if I have 10x squared minus 25x plus 35 divided by 5, it's like I took each one of those terms and divided them by 5. Then I'm going to complete the reduction. 10 divided by 5 is 2, 25 divided by 5 is 5, 35 divided by 5 is 7. So there is my simplified resulting polynomial. Now I can check this answer by multiplying that by 5, and I should get the same thing that I started out with. The 5 is called the divisor, so sometimes in the problems in the lab, you'll start seeing that technical terminology. So 5 would be the divisor, the quotient would be the answer that results, and the original polynomial is also known as the dividend. Here are two other examples. Now what you'll notice in these examples is now I have variables in the denominator. And from our exponent rules, we're going to do subtraction. So x to the fourth divided by x to the third. You can either think of this as you're canceling 3 out of the 4 x's in the term, or you can think about it as 4 minus 3 is 1. So we're going to take and divide 4 divided by 4, which is 1. I have 1x remaining. 7 divided by 4, I can't reduce. X cubed and x cubed, 3 minus 3 is 0, meaning I have no x's. And then if I have x squared divided by x cubed, I can cancel 2 x's in the numerator, and I have 1 in the denominator. Or you can think of it as 2 minus 3 is negative 1, so I have 1x remaining in the denominator. There are two different ways to think about it. No way is better than the other. In part C, the first thing I want to do is divide them up. And then I'm going to simplify. So 6 divided by 1 is 6. I can cancel 2 a's in the top, but I still have 1 left in the bottom. Then the next term, 9 divided by 1 is 9. I can cancel the a to the third in both the top and the bottom, and I'm left with 1b in the bottom. And then in the last term, I can cancel all the a's and all the b's. So really this is going to be a term by term. You want to look at it term by term, divide the numbers, then attack the variable portion. To divide a polynomial by another polynomial, so now we're talking about 2 or more terms, that's going to be slightly different. Let's take a look at how to do this. We would write it out as if you were dividing whole numbers. Think long division here. So basically, we're treating this like a long division problem. So I want to divide the first term by k plus 6, and then I'm going to write the result at the top. Well, I can't do k plus 6 doesn't go into 2k squared. So then just like in long division, you would put the 0 here, and then now you're looking at, does k plus 6 go into 2k squared plus 17k? So now I can take this and I can see if it goes into that as a factor, and I get 2k, because 2k times k plus 6 is going to become this polynomial. Then I look at the 30, and I can't go into 30, so I kind of have a remainder happening here. So when I do the 2k squared plus 17k, I get 2k, and I have the resulting remainder of 5k plus 30. Well, we know k plus 6 can't go into 30, but the question is, it can go into 5k plus 30. If you factor a 5 out of that k plus 30, you're going to get k plus 6. So if you're not sure how to do the division, look at 2k squared plus 17k. I can factor a k out of this, and I can also, I can't factor anything else out. So the closest I can get to it is 12k. So this is a little bit more of a difficult method. Synthetic division might be more your jam, and you can definitely use synthetic division in place of this long division process. And I'm going to post a video on that as well. Here's another example. This is the long division method. I would probably attack this with synthetic division. Again, I'm going to have a video posted on how to do synthetic division, but this would be how you would run through a long division problem. I think a lot of times long division, if you learned it in school, it can be intuitive for some students, but for the most part, you're going to want to probably use synthetic division. Here, I could use synthetic division. I can factor the m term out to be m times m minus 5, and I can do synthetic division with that twice to get the answer, or I can do the long division. Again, my preference is going to be the synthetic division, but I'm not you. You need to do what makes the most sense to you. So if I was tackling this via long division, the closest I could get to 4m to the fourth minus 23m cubed would be this, to get this, because I would take this term and I would multiply it by 4. So I would get 4m to the fourth minus 20m cubed. So that's where this is coming from. Then I'm going to actually subtract them, and I'm left with this 3m cubed. I'm going to bring the 16m squared down. The closest I can get to this would be if I multiplied by 3m. And so if I multiplied by 3m, this is what I would get. I'm going to complete that subtraction. I'm left with m squared minus 4m. And the closest I can get to that is what I have. But when I get to what I have, I'm going to have this negative 1 hanging out here. Drop this 1 down. Or I'm going to have negative 4 minus negative 5, so it's plus positive 1. And I'm going to have a remainder because I can't put m squared into m. Here's another example. Again, synthetic division might make more sense, but I can take this 4x plus 8 and I can multiply it by 2x squared, and that's where this comes from right here, this term. Then I'm going to complete the addition or subtraction. Then I can take, well, the closest I can get to 5x squared minus 2x would be to multiply that by x and work with that. That's about as close as I can get. I can multiply it by 5/4 x to get that nice 5 in the front. So those terms cancel. And then I'm going to carry on, and there's my answer. So again, synthetic division might make more sense to you, but that's okay. Either method is fine. When I'm dividing by polynomials, I show it with this division symbol. So I'm showing f divided by g of x. F divided by g of negative 1 is going to be much easier than dividing the two polynomials. You can actually take negative 1 and plug it into the f function, take negative 1, plug it into the g function, and divide the number answers. So you can do that as long as you don't get a 0 in the g function. Or you could actively take that division and you could actually divide the polynomials yourself, like we did earlier with this, and then plug in negative 1. I honestly would plug into f, plug into g, and then do the division of the numbers, so I don't have to deal with the division of the polynomials. Here, I don't have numbers, so I have to go ahead and tackle it with this method. And again, you could use synthetic division here as well. If you don't want to use long division, synthetic division is definitely a possible option here. And I would get to my answer. So the key here is you have to do what works for you. I've mentioned synthetic division a couple times. Definitely do what makes the most sense to you, because at the end of the day, that's what we're looking for.